Today I'm going to explore 14 Python libraries that you probably haven't used, but you should. And at the end, I'll include a bonus one. It's not a library, but it's really nice and you should definitely check it out. Before we dive in, if you're building a new project or you just want to get better at structuring your code, check out my software design guide at ArjanCodes/design guide. It's a practical checklist I follow myself when designing new software. It's totally free and the link is in the description. The first library that I want to talk about is Toolz with a Z, or PyToolz. Already when a library ends with a Z, you know it's going to be pretty cool. Actually, PyToolz is a functional programming toolkit for Python and it enables things like compose, query, partial and high performance data manipulation pipelines. Now, some of these things like partial function application are already available in functools standard library package, but compose isn't. And having a compose function can sometimes be helpful. For example, here's a really simple piece of code that imports the compose function from Toolz, and then it composes stripping a string and turning it into uppercase. And then that gives us a new function and that we can use to then strip and convert a string to uppercase. And when you run this, then this is what you get as a result. So Toolz is really nice just for writing functional code without going full Haskell. The only disadvantage is that there's not really any type annotations for this library, and I feel like that's sorely missed here. It would be really helpful to actually have proper type annotations. There's been an open issue for adding static typing to Toolz since 2020, so that's been a really long time, so I hope they'll get to it eventually because it would definitely be helpful. The next library that you should know about is Tabulate. This is a really simple, easy to use library that cleanly formats tabular data for the console. Or Markdown, LaTeX, it can do a lot of different things. This is really nice when you're developing a CLI and you just want to print some data and see what is going on. Or if you just want to debug some output. Using Tabulate is really easy. I have some simple data here, a list of lists, and then I can simply call Tabulate. I pass the table, I supply the names of the headers, and that's going to print this data as a table in my terminal. There you go, really straightforward. As you can see from the documentation, there's a ton of other options as well. For example, you can add row indices, you can change the format of the table. So it can be, for example, LaTeX output if you need that for, I don't know, a paper or something. And it can also print your tables in a grid like this or like this. There's tons of different options available. In short, Tabulate, really simple, really nice, highly recommended. Now, talking about printing stuff to the console, another library that's actually really nice is Rich. And this allows you to create really nice looking console output. This also includes tables, but syntax highlighting, tracebacks, progress bars. It's kind of a drop-in replacement for print, but with a lot more power. Here's a very basic example. So I simply import print from Rich, and then you can add these types of tags to, for example, change the color of the text. So when I run this, then this is what you get. Now, Rich can do way more than just change the color. For example, it can print JSON by using the print.json function. Or you can do easy alignment of text, like so. There's also support for paging, which is also quite interesting if you have pretty long input. And like I said, Rich can also print tables. It's a piece of code that shows you how to do that. This is kind of a different approach from Tabulate, which is really about taking some data and then just being able to quickly print it as a table. In Rich, there is a more structured approach to it where you have to create a table object and then add columns and rows, which, you know, also works, but Tabulate is a bit simpler if you just have some data that you want to quickly print. The next library that I want to show you is Hypothesis. I've talked about this library before. So if you're doing software tests, like you're writing unit tests, for example, you often have to deal with different types of inputs, right? The empty string, 0, negative numbers, positive numbers, etc., etc. Now, instead of manually defining all of these cases, you can also approach it slightly differently by using something called property-based testing, where instead of providing all these separate inputs, you describe the shape of the inputs. And then this is going to generate test cases for you. And this is really nice for discovering edge cases or even thinking of edges that you didn't even consider. So here's an example of how that could look like. So you have to do a couple of imports from the Hypothesis package. But As you can see, I have a simple test function here that checks whether sorting is idempotent. Then what you can do with hypothesis is use a decorator kind of structure to indicate what kind of thing you're supplying to a particular test. So in this case, given is various lists of integers. This already shows you the power of what you can do with hypothesis. So this basically generates a bunch of different integer value inputs. And this generates a bunch of different lists, including probably empty lists, lists with one element, all different kind of cases. And then this test is not going to be run once, but it's going to be run for all of these different cases. And then it's going to check this assert. So how does this work? Well, if you're simply using PyTest, and this is somewhere in your test folder, then you simply run PyTest. Now in this case, I have an explicit example, so I call PyTest on that particular example. As you can see, it collected the test and the test passed in this case, because of course, this will always be correct, right? So if you want to level up your unit test, hypothesis is a really great place to start. Next up is Pydantic-settings. This is actually a really cool little extension of Pydantic. It adds built-in support for managing environment variables and application configuration. I mean, you always have to deal with some level of configuration of your app, right? You may need to load a database URL from somewhere or use environment variables. And you don't want to be writing a boilerplate Python code in order to load those settings or retrieve them directly from environment variables all over your code. This is going to be a mess. And you also want to maybe do some validation, like making sure that certain settings are there before you actually run your script. And that's what Pydantic-settings allows you to do. It's just a simple package that you install separately. And then what you can do is define a Pydantic model and then use that as a setting. So I've created a really simple example here of what that could look like. So as you can see, I'm importing base settings from Pydantic-settings. And then I'm going to create a class, in this case called settings, that has a bunch of different settings. In this case, just two, a database URL and a debug flag. And then, this is actually the interesting bit, I created a config class where I defined an env file, or you can define any file that you want here. In this case, I have settings.env. In my settings.env, so this is typically something that you store in your server, or it's in any case not something that you will store in your Git repository. And that's where we have the actual settings. So there's a database URL and there's a debug flag. And what this part does is that it says that basically you take the default values from this particular file. So then when I create an instance of this settings object, it's going to take the values from this file. And then I can simply access them directly. I get type annotations and everything, which is really nice in my IDE. So it's really easy to use. So when I run this, you see that we now have access to these values that are from the .env file, which is really nice. And on top of that, there's like a ton of stuff that you can modify, like whether it should be case sensitive or not, how you should parse certain environment variables, etc., etc. So I recommend you try this for your setting. It works really well. Next up is Httpx, which is an improved version of request. It adds, in particular, async support, there's connection pooling, and overall better performance. And in many cases, it's actually drop-in compatible with request. So I've now switched completely over from using request to Httpx. Works really well and it's really easy to use. Here's the most basic usage, which doesn't use any of the advanced features, but you can simply do httpx.get. And then you have your URL. So in this case, this retrieves information about one of my courses from my business API. And then you can simply print a response JSON data. And here you can see the results. So this was actually my software designer mindset course. But there are way more things that you can do with Httpx. So this is a single connection request, but you typically want to create a client and then use that client because that's going to improve the performance. And that's actually really easy to use. For example, in Httpx, you have an async client that you can create. And then you can, if you create that, what you can see here, so this actually uses a context manager, but then you can actually use await to do get request and do multiple requests at the same time, etc. and get all the advantages of concurrent code. Now, like I mentioned, there's a ton of other things you can do with Httpx as well, like connection pooling, for example. If you're still on request, I highly recommend you switch to Httpx. Next up, and this is something that I've always been struggling with, and I'm really happy that there's a library for this. It's FastAPI-pagination. Now, if you're building an API and it accesses resources, like, I don't know, you have an endpoint that searches for resources, for example, and you want to support pages because you don't want to send back thousands and thousands of objects in a single response, well, you need to write some boilerplate code to deal with pagination. Like you may want to set like a skip and a limit, for example, or you want to do differently where you're actually sending back some key that allows you to then navigate to the next page. FastAPI-pagination adds support for these things for FastAPI. So it's really cool. And here you can see a simple example of how you're supposed to use this. So in this case, your GET request, in this case for getting users, gets not a list of users, but it gets a page object. And then you call paginate on the result to actually deal with that. I also created an example of this. So let's say if you have a Pydantic model of an item, which has an ID and a name, I then created a fake database containing lots of these items. Doesn't really matter what they contain. And then I created a paginated endpoint for these items. And then finally, I can run the script as a UV-Corn server. So when I run this example, like so, now I have my server. What I can do now is navigate to the items page. And as you can see, this gives me the first 50 items. So that's already really nice that paginate adds this automatically. But if I pass query arguments like page is 3 and size equals 10, then I'm getting this as a result. So all of this is handled by FastAPI-paginate. Really, really nice. If you're building APIs, adding this is a no-brainer in my opinion. Next library that I want to mention, I don't have a specific example for this because it requires some extra setup, but it's FastStream. And this is an async event-driven framework that's built on top of async.io, but it makes working with services like RabbitMQ, Kafka, Redis, etc. Redis, I never know how to pronounce it, but it makes it much easier. I like Redis actually because it's kind of the counterpart of Redis. Yeah? What do you think? Anyway, it's pretty cool and works with the Python decorator mechanism to add some features. Like, for example, here there's a Kafka example where we create a broker and you pass the URL of the Kafka server. Here, for example, this decorator allows you to consume data from this incoming data stream, and you can output it to another one via this simple return statement. That's actually pretty nice. Another thing that's nice is that it actually integrates with Pydantic as well. So you can define messages with a Pydantic base model, and then FastStream will use that to pass in the data. You can add validation and anything you want. You get all the advantages of Pydantic. So FastStream, really nice if you're using services like Redis, Kafka, or RabbitMQ. Next up is NiceGUI, and this is a full-stack Python framework to build modern user interfaces just with plain Python. It has real-time updates, charts, tables. You don't need any JavaScript, and it supports both web and native deployments. And here's a very simple example of how this works. So I have imported UI from NiceGUI, and I can simply write UI.label. I add a button. I have an on-click handler, Lambda function in this case, and I can add a notification, and then I simply run the app like so. And when I run the script, it already automatically opens the browser for me. And then I have my nice little GUI, and I can click this and I get the notification here at the bottom. So already by just defining these basic objects, it already looks pretty good and it's already pretty easy to get started with. So to me, this is a really important aspect of a good user interface library, that it's actually easy to use. And NiceGUI has most of the features that you actually want in a user interface, including very nice layout possibilities. So for example, you have all the standard things that you would need, like menus and cards and columns and rows in a grid, a list, there's a slide, there's accordion style things like this, basically all the elements that you want. But if you don't like the way that NiceGUI works, there are alternatives like, for example, Flet, which allows to build multi-platform apps in Python, and in the back it's powered by Flutter. As opposed to NiceGUI, Flet is a bit more focused on building native feeling apps. And then you can build apps with Python that run on your desktop, your mobile, or on the web. And here's an example. Welcome to Utrecht. Here's an example of what using Flet looks like. So it's slightly different from UI, but you kind of get the feeling of this as well. So you get a page in your main function, and then you can add elements like text in this example. And then you simply run it like so. And as target, you pass the function that needs to run. And when I run this, you see that it doesn't open a website. It actually starts a desktop app with the text element in it. Now, Flet, just like NiceGUI, has access to all these different kind of controls that you have, like all sorts of buttons. For example, there is dialogues, there is navigation elements like an app bar or a menu bar, etc., etc. Basically anything that you need. So if you want a more native experience, try Flet. Now, if you also don't like that, maybe you like something that is a bit more React style. I don't know why you would want that, but if you do, then actually there is an alternative to Flet or NiceGUI, and that's called Reflex. And that allows you to build full-stack web apps using a React-style component tree in Python. And this combines state management, component rendering using a declarative approach. Here's the Reflex website. We can go to the documentation of how it actually works. And again, you have all the components that you would want, right? So again, you have your layout things like a sidebar or navigation bar. There's checkboxes, there are the speed dial, pricing cards, lots of different things. And when you take a look at some of these user interface, you can also see the code that actually powers it. And it very much reminds me of React. So you have your function where you create a component, and that component contains other things. And that's basically how you define everything. Personally, this is not my preferred UI library. I like NiceGUI in particular. But if you're really used to working with React, then Reflex might be a good option for you. Next up is Textual. And this is a terminal UI framework for Python. And this is actually built by the creators of Ridge. Now, I believe they stopped the company actually, but the open source libraries, Textual and Ridge, they remain. So you can still use these. And this is basically kind of like a NiceGUI. And what this allows to do is create these sort of text-based user interfaces. And this is nice if you want, I don't know, some type of terminal dashboard or for admin tools or whatever. And the way this works is pretty simple. You have an app class, and there's a compose method, and there you yield the actual thing that you want to render on the screen. Here you see a slightly more advanced example where we have a clock, and you can supply some CSS. That's what you see here. There is this compose function that I just mentioned. And then you can also do interactive stuff, like here we update the clock, and then we set an interval so that the clock updates itself every second. And then there is the actual update method. So maybe I should just run this example and see what happens. Well, and there we go. We have our clock, and it's almost lunchtime for me. By the way, if you're enjoying these videos and you'd like to keep updated on the latest Python news, check out my weekly newsletter, The Friday Loop, where I share news about Python and software development in general. You can sign up for free at thefridayloop.com. I want to finish this video with a few AI frameworks. I mean, we're all building with AI nowadays. It's really important, and it's going to be integrated more and more in the things that we do. So what are some of the libraries, packages that you can use for that? Well, one of them is LangGraph. It is built on LangChain, but it's more focused on defining agent flows as graphs. So you build the logic of multi-step AI workflows with nodes and edges. So this is great for orchestrating AI agents with branching logics, conditionals, and loops. Here's an example of the kind of thing you can do with this. So let's say you have a bunch of these different agents that communicate with each other. So you can actually define all of this in Python by creating these different agents. And then you can create, for example, a supervisor agent that uses these other agents. But next to supervisor, there's also other options like a swarm of multiple agents, or you can interface with an MCP server. There is a memory management, lots of different possibilities. Now, LangGraph is nice, but actually Pydantic AI which is next up in this list, might be even nicer. And this is, you could say it's tooling for integrating Pydantic with LLMs, where you can use structured validated schemas to define the shape of LLM responses. But it has other things as well, like for example, dependency injection. There is support for graph. It integrates with Pydantic logfire. It's type-safe, Python-centric design. So these are all really nice things. The basic way you set this up is really simple. You just create an agent, you supply the model that you're going to use. There's a system prompt, and then you can simply run that agent. But you can do other things like dependency injection. So here's another example of an agent, and there you supply dependencies. So in this case, these are support dependencies, which is a customer ID and a database connection. And then you can add tools to that, like a function that retrieves the balance of the customer. Or there's sample system prompts for adding a customer name, for example. And on top of that, you can supply the output type. So in this case, that's a support output model. So that means you also get a structured schema for the output of an LLM. So there's no more magic strings that you have to deal with. So overall, I feel like this is also a really nice design to deal with agents. And perhaps you don't need very complicated agent structures, but you would like to have validation, some custom prompts, some integration with toolings. PydanticAI is a really great way to do that. And by the way, if you want me to do a more in-depth video just covering PydanticAI and what you can do with it, let me know in the comments. Now, I told you that was a bonus, and it's not a library, but it's actually a tool that is really useful if you're working a lot in Python, and that's Marimo. I'm not really sure. I'd say Marimo. Anyway, whatever we're calling it, however we're pronouncing it, this is a fresh take on interactive Python notebooks. So there's no hidden state like in a Jupyter notebook. UI updates reactively based on the code. And what is actually really nice, in particular what I like about Marimo, is that it doesn't use some custom format or something. It's just a piece of Python code. And I can actually show you that in their online playground. So let's take a look at one of the tutorials. For example, this is all done in the web interface, but you can also run this as an extension in VS Code. But what you can see here, we have a notebook style setup. So we can add elements to this or edit this in any way that we like. But if you look at the files, you see that there is not some custom file. There is actually a Python file. And you can take a look at the actual code in the Python file. And as you can see, here is a markdown element that's reflected right here. We have cells defined with a decorator. There's a slider. All the elements are here. This is completely defined by this piece of Python code. And that's nice because that means you can also put this in a Git repository. You actually work with Python code, so you can maybe even write some custom code that interacts directly with this in some way. There's a ton of built-in components for inputs, sliders, like what you can see here at the top. So this just works, which is really cool. There's charts and there's more. So if you're frustrated by Jupyter notebooks and how to use them, Marimo might be a really good option for you. And like I said, Marimo also has a VS Code extension. So if you're using VS Code, they can simply install this extension. And then you can use Marimo directly in VS Code. Yes, we trust the publisher. Hopefully this video gave you a few new interesting tools and libraries to play with. But I'd like to hear from you. Which of these are you already using? Do you have a favorite Python library that I didn't mention? Would you like me to do a deeper dive on any of these libraries? Let me know in the comments. Now, in order to effectively use these libraries, you need to know what to do and what not to do in Python code. And this video shows you exactly how. Thanks for watching, and see you next time.